first part just gave you an area. And in the directions, it said, well, you have to find between what two z-scores if you looked up in your table. If you do an inverse norm, just round to your two positions. Now, they're assuming this time this is all area to the left. So, did anybody have a problem with the first 6 or 7 that are here? Question with 5.
That's more than 3 decimals.
Well, this one happens to fall exactly halfway between. If you rounded this one to 1.65, that's fine. Or 1.64, I think it's 1.64 if you're going to round it. Yeah, that's fine. What happens to this one if you look on your table? That's one of those that is exactly in between. If you look up your table, and everybody do this with me so that you understand exactly what Jade is talking about. Find the 0.05 on your table. It's going to be in the negative side because it's less than 50. And we don't exactly have a 0.05. We have a 0.0495 and a 0.0505. See how this one falls exactly halfway? So it took the negative 1.64. Oops. Number 5. It took the negative 1.64 and it took the negative 1.65 and said it's halfway in between. This one, if you looked at your table, is halfway in between. If you look at your calculator, you don't realize that it's halfway in between until you see that 5 at the end. And if you did it as this one, that's fine. When we use a table of all these z-scores, that's one of the ones that we do out 3 decimals, and we do another one out 3 decimals. This one will go out 3 decimals. But if you do it to 2, I'm fine. Most of the times you do your calculations in your calculator, so that's fine. This was one of those, if you did it in your calculator, you're going to round to 1.56. If you do it by the table, it's another one that was halfway through. Okay, I just want you to be aware of what extrapolation is. Extrapolation is when we do this. When we take it halfway through. Remember the other day we looked at one, which one is it closer to? We subtracted them to see which one was it closer to. When it's not halfway, we just leave it which one is it closer to. When it's halfway, we sometimes throw the extra 5 out there. Was everybody good with this? If you're ranking 88%, remember you read from left to right. This is the 50 mark. So another 30 gives you here. And what your sketch is going to do is make sure that you're in the positive if you need to be in the positive, or the negative. This one, it's less than 50%. So somewhere over here is 20%. All I want is a rough sketch. I don't care where you put the line here. I do care if you did it here, because that would be wrong. So I want you to kind of give me a sketch. Where is 99.16? Well, it's all through there. It's most of your curve, right? So are you guys able to do the sketches with it? Sketches are really important. You need, like, placement. You need this to make this actually make sense. This one, do you see the symmetry here? Your curve is 100%. So if you're 25%, you're sitting down here. If you're 75%, 25% is sitting up here. So do you see the positive and the negative of that z-score? God bless you. How many of you actually looked up the 75? Did you realize it was I'm sorry? That's fine. But do you see now? It's symmetric to your graph? Yes. When you graph it, you should see it better. Because this is 25% here, this is 25% here. So they have to, God bless you, have the negative z and the positive z.
It was like the same function with 23.
Yeah, yeah. With the when they gave you the shading. Okay. These good? Anybody have a problem with these?
I didn't get it negative.
For which one? 13?
Yeah.
So 25% of your curve has to be less than 50, right? So it's got to be here somewhere. So when you look up your area inverse norm, you're going to look up 0.25.
I put 26, 24.
0.674, you just try to get your z-scores 2 decimals.
First.
Mm-hmm. Okay. Again, they gave you area to the left, inverse norm. Put that in your inverse norm. 2 ways to do this, guy. Inverse norm, and remember I showed you yesterday, let inverse norm subtract it for you. You won't make any mistakes that way. You still have your mean of 0, your standard deviation of 1, but put the 1 minus. Your calculator takes that. So this is to the right. Now another way to do this is if you did an inverse norm on this, obviously it's way over here. It's going to give you a positive, right? Just take the negative of it because your curve is symmetric. The 0.05 in both tails, well, if it's even on both ends of your curve, they have to have the same z-score. One negative, one positive. So you just look up your negative side. Inverse norm, 0.05. That'll give you your negative 1.64 or 1.65, whatever you did. And then you know you have the positive one. Good? The last few, be careful moving your decimals. Again, look at 23 and 25 like Imani pointed out. They're the same as our 25 and 75%. It's the same area to the left. So when I do this, if this is the same exact area, isn't this going to be the positive of that z-score? That's the part I want you to see. I need you to see the symmetry. Finding the 80% in between, it's symmetric about the mean. Another way to do this, besides the 1 minus that, and then split it in half, is look, what's half of your curve? 50. So if I took half of 80, 40, and I subtracted these, aren't I looking up an area of 0.10? Use the curve. There's many ways to see this on your curve. You need to know the total area is 1.
You just subtract.
Uh-huh. And divide by 2. Yeah, absolutely.
So 0.10 is your answer?
Well, 0.10 is what you're looking up.
Oh.
You got to do an inverse norm. And remember, in your inverse norm, you can actually do this. 1 minus 0.80 divided by 2. You can put that in your inverse norm so that you don't even have to make a mistake with that. It's a little trickier with the 83s because the 83s, they give you a parentheses to start. You're going to actually have to do 2 groupings. 1, and then put this in, the 1 minus 0.80. Sorry, that doesn't belong there. Divided by 2. That goes to this, comma 0, comma 1. It's a little trickier with the 83s. Yeah.
So the answer for that one, when you put in the 0.10,
Yeah.
whatever answer you get, that's your answer for that one?
Well, whatever answer you get is that negative.
Uh-huh.
And that's the positive of it. God bless.
Bless you, God bless
Bless
you.
you, bless you,
Bless you, God bless you.
So this is a very thoughtful group today. Number 29 is a little tricky. Number 29 reads, find the z-score for which 5%. It's the same as the 80, it's the same as the 95%, but it's 5%. So it's a little tiny space that you need. Now, remember, you're symmetric about the mean. So right along here is where your 5% is. Again, you can do 1 minus 0.05 divided by 2, or you can use the concept this is 50. Use your 50 minus half of 0.05. Bless you.
Bless
And look that up instead. Does everybody see 2 ways to do that? Okay. Good.
you. Negative
Good. Yeah. Well, you got to have a positive and a negative. So you found the negative, and then you also have the positive of it. It has to be symmetric.
Did you just take minus 2.5 then?
0.025. If you're going to use the 50 concept, then you only want half of the 5%, which is 2.5%, 0.025. I kind of like the 50. I like the 50 minus. Then you don't have to worry about a set of parentheses in there. Because what ends up happening is, if you do not put this parentheses over here, guys, it's going to do this. It's going to do that first. So I kind of lean towards the 50, but whichever way you do it is fine. Just before you hit enter, look it over and see what order of operations it's going to do. That's the tricky part. Questions? No? Okay. So we use this formula. Do you have to know how to get it? No. But I want all eyes up here, and I want you to watch this formula that you know for your z-score, and we're going to transform this, and we're going to solve for x. So I would cross multiply. All I want you to do is watch. I cross multiply, okay? Solve for x. I add the mean to both sides. This is the formula to find an x value. We use the same formula, but we transform it. Remember in algebra, if we're going to find like a distance equals rate times time, if I'm going to give you the rate and the time, you're going to keep plugging it in. If I'm going to give you a distance and a time, and you need to keep finding the rate, then you solve for r. And now you plug it in constantly, right? It's just transforming your equation for the one that you're going to solve for over and over.
Do we ever have to find standard deviation?
Well, you know how to. You could put it in your L1 and find your mean and your standard deviation. Yes. Right now, I'm giving you those so that we can find your x values. So this is the formula we're going to use to find your x values. We still need a z-score, we still need a standard deviation, and we still need the mean. You just found out how to find the z-score, given an area, given a percentile, and we can go ahead and do this. So let's give this a try. Example 3. Tell me a second here. Page 254. It says, and this is 254. This is why we really work on this part of it. These are the important parts. What is the cutoff weight? What is the cutoff height? What is the cutoff SAT? What is the cutoff grade? These are things that when they make a box of cereal, what is the cutoff weight I need? Because if it's too heavy, I'm losing money. If it's too light, consumers are after me. So I need a cutoff on these things. A veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9. Pull this out. Mean of 9, standard deviation of 2. You're going to find the weights that of which we call x, that's your variable, that corresponds to a z-score of 1.96, of negative 0.44, and of 0. We're going to start with the sketch. Remember how I combined mine? So we're going to combine these again. Put your z-scores on the bottom, and we're going to put your x's on the top. 9. We're going to add the standard deviation. 11, 13, 15. We're going to go the opposite way. 7, 5, 3. Nice easy one to add down. Right? Now, we're going to find where this z-score is. 1.96 is right about here. Here's the 1, here's the 2. 1.96 is right about here. Does it say negative? But it does happen to me. I lose my negative signs. So, What x-score is it going to be very close to?
12.
It's going to be very close to 13, between 12 and 13, right? It'll be between 12 and 13. So to do that, we're going to use that formula. We're going to use our transformed formula. This is really easy. Just stay with me. So we take the standard deviation, which they gave us. We take the we take the z-score, we take the standard deviation, we take the mean, and you put that whole thing into your calculator. It's already transformed. We transformed it. What'd you get? 12.92. Now, does that make sense? Shouldn't it be real close to the 13? Yes. Okay, so let's try another one. Negative 0.44. Between which two standard deviated z-scores do those come between? Which two ones do they come between?
0 and negative 1. 7 and 9.
0 and negative 1, between 7 and 9. And it's almost halfway, so I'm looking real close to the 8. So let's do this one. Take your z-score. It all works out if you keep the negatives and the positive where they belong. Okay? Put it into your calc. God bless you.
Bless you.
God bless you.
So what'd you get for this one?
8.112.
8.12? Ah, and isn't that where we expected to find it? This is really why we do this, to find your cutoff values. I want to know, now remember, isn't negative 2 and positive 2 unusual? So maybe I'm the veterinarian and I say, what weights would be unusual for my cats? If I do this, I know anything 5 and less is unusual. Anything 13 or more is also unusual. When a vet says to you, your cat is 14 pounds, oh my gosh, what a fat cat. That's because they look at the average, they look at the standard deviation, and there's a cutoff. She calls my dogs the fat man and the fat boy. One's older, one's younger, so it's a fat man and a fat boy, and they're really not even that fat. They're just big dogs. We say they're fluffy. So, but this is where these cutoffs come from. Nobody randomly says, this is what I think of these numbers. Most of your scores, guys, if you remember, come between the plus or minus 1. So what your veterinarian is probably saying is, I should see your cat weighing somewhere between 7 pounds and 11 pounds. That's where all this ties in. Make sense? Now, a z-score of 0, we can do this if you want. 0 times 2 plus 9. Ah, but isn't it right there where my 0 is?
Yes.
But I wanted to show you it still works with your formula. You can pull that right off your graph. So these are why we have cutoff points. And if this is very unusual, we can say a cat with a weight of 3, that's really dangerously low, on the low end. Very unusual. A cat with a weight over 15, ooh, really, really, really on the high end. So these are where your cutoffs come from. And I need your charts to just like we did last week or the week before. Put your z-scores on the bottom, put your x-scores on the top. There's no shading for this one yet, because right now they just asked us to find the values. Yours always either gives you a z-score or an x value. I like to put them both together. So let's take a look at another one of these. Okay, we can find those. Okay, let's do this one. Scores for a California police officer standards and training test are normally distributed. Notice how I always tell you this. If they don't, you can't do these problems. You can't make a normal curve for something that's not normal. With the mean, pull it out, and a mean of 50 and a standard deviation of 10. These are the first things that you're going to pull out. You want to hire only applicants with scores in the top 10%. Yeah, I don't want the bad ones. I want all the good ones. I'm a police officer. training part, and I want the good scores. I don't want the low-end scores. So I want the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired? They have to be in the top 10%. So the first thing we're going to do is make a curve. This is going to tie your area together, finding your z-score, and it's going to find your cutoff value. This is really important. Make sure you're doing this with me. So let's put your mean across here. 50, this is 60, 70, 80. And go down. 40, 30, 20. I want the top 10%. Would I find it on the right-hand side of the curve or the left-hand side of the curve?
Right.
The right-hand. Somewhere over here is my top 10%. So the first thing I need to do is find the z-score for a top 10%. I want the area to the right to be 1.0. So how do I find that z-score? Okay, and what would you say in your calculator?
1 minus.
Oh, very good. 1 minus 0.10, because remember, we only look up the areas to the left. If you put in the 0.10, you get the negative. Then just drop the negative sign. So put this in your calculator. Still put in your 0 and your 1 for now. Still 0 and 1 because I want the z-score. So what is your z-score? So I'm sorry? 1.28. Good. Now we're going to use your formula. X is equal to the z-score times the standard deviation plus the mean. 1.28 times 10 plus the mean. This is going to tell me what's the cutoff score. So my cutoff score is 62.8. Right? Now, I need to round this. So let's just take a look at this for 1 second. Here's my cutoff for this. This is at 62.8. Should I round up or down? I need to be in that top 10%. Up. So I need a score of 63. As those papers come by, anybody with less than 63, I don't look at. Anybody with 63 or more, I take. I got the top 10% of this group. I got the cream of the crop, which is what I want on my police force. Right? So this is why we do this. Now, be careful of your rounding. Even if that said 62.2, I can't go to 62 because that would put me to the left of this top 10. I need to be inside that shaded area. So in this case, you're rounding up. When we're on the opposite side, we're going to round down. So we got to take a look at your shading when we do rounding as well.
Even if it was like 62.1.
We still have to go up because they can't get a 62. They need to get a 63. Okay? Questions? Okay. No, because Monday we'll finish this off.
Word.